Today we're delving into Unit 3.2 of the first half of General Chemistry, which covers chemical reactivity. If you find value in this video, please like it and let people know about the channel because it really does help. Chemical reactivity refers to the ability of a chemical substance to undergo chemical reactions with other substances. This is a fundamental concept in chemistry because chemical reactions are the basis of all chemical processes and transformations. The reactivity of a substance is determined by the nature of its chemical bonds and the electron configurations of the atoms or molecules. As noted previously, chemical bonds are formed by the sharing or transfer of electrons between atoms or molecules, and the stability of these bonds depends on the energy required to break them. The more easily a bond can break, the more reactive the substance will be. The reactivity of a substance can be influenced by a number of factors, including temperature, pressure, concentration, and the presence of catalysts or inhibitors. For example, increasing the temperature of a reaction can increase the reactivity of the substances involved by providing more energy to break bonds and initiate reactions. Three of the most frequent types of reactions are called combination reactions, decomposition reactions, and combustion reactions. Combination reactions are a type of chemical reaction in which two or more substances combine to form a single, more complex substance. In other words, the reactants combine to form a product. The general equation for a combination reaction can be represented as follows: A plus B going to AB. In this equation, A and B represent reactants, and AB represents the product. The reaction is often exothermic, meaning that it releases energy in the form of heat. One common example of a combustion reaction is the reaction between hydrogen gas, H2, and oxygen gas, O2, to form water, H2O. The equation for this reaction is 2H2 plus O2 going to 2H2O. In this reaction, two molecules of hydrogen gas combine with one molecule of oxygen gas to form two molecules of water. Decomposition reactions are the opposite of combination reactions and are a type of chemical reaction in which a single compound breaks down into two or more simpler substances. In other words, the reactant decomposes into two or more products. The general equation for the decomposition reaction can be represented as follows: AB going to A plus B. In this reaction, AB is the reactant, and A and B represent the products. The reaction is often endothermic, meaning that it requires energy in the form of light or heat. One common example of a decomposition reaction is the breakdown of hydrogen peroxide, H2O2, into water, H2O, and oxygen gas, O2. The equation for this reaction is 2H2O2 going to 2H2O plus O2. In this reaction, two molecules of hydrogen peroxide break down into two molecules of water and one molecule of oxygen gas. This reaction is also an example of an endothermic reaction because it requires energy. Combustion reactions are similar to combination reactions since it's a chemical reaction that has a substance combined with another substance. However, in combustion reactions, one of the substances is always oxygen gas, O2. These reactions are typically exothermic, meaning that they release energy, and the general equation for a combustion reaction can be represented as the fuel plus O2 going to CO2 plus H2O plus heat or light. In this equation, the fuel is typically a hydrocarbon, which is a type of organic compound that consists entirely of hydrogens H and carbon Cs, atoms such as methane, CH4. During the reaction, the carbon and the hydrogen atoms in the fuel combine with oxygen to form carbon dioxide, CO2, and water, H2O, respectively. The release of heat and light is a result of the energy released during this reaction. We highlighted the combustion reaction in Unit 3.1 of the series with the combustion of methane. Based on what you learned, think about the following question. Classify the following reactions as either combination, decomposition, or combustion reactions. 2Li plus F2 going to 2LiF. CH3OH plus O2 going to CO2 plus 2H2O. BaCO3 going to BaO plus CO2. Thank you so much for spending your valuable time learning and bettering yourself. If you like the video and want to learn more, donate, or get tutoring, please check out my website, nocollegeneeded.org. You can use the code NCN for 20% off tutoring and any supplemental materials. If the subject isn't up yet, please be patient. I'm working on bringing them up as soon as I can.